Hey there. Today we're going to talk about evaluating functions, and we've done a little bit of that already by just direct substitution. Today we're going to look at substitution into some different types of functions, not just polynomial functions, as well as we're going to look at piecewise functions and as well as evaluating by synthetic division. So let's start here. We are going to use these three functions, and for each of these three functions we are going to evaluate f of 2.9. Okay, so just like with a polynomial function, when we have a function defined, f of x is equal to e raised to the 0.0247x, and we want to evaluate f of 2.9, then in each case that we see an x, we are going to replace it with 2.9. So e raised to the 0.0247 times 2.9. Now, I don't know this off the top of my head, and I'm thinking that probably you don't either. So that's where I pull out my handy dandy calculator, and as you can see, I've put this value in, e raised to the 0.0247 times 2.9, and I ask my calculator, nicely of course, what that value is. And it says to me it is 1.07425. So I would say that if it doesn't give you directions, round to 3 decimal places. So we would call this 1.074. Okay, so this next one we're looking at, log base 2 of x minus 5. Again, we just replace everything that we see x in by that 2.9. And now I'm looking at evaluating a logarithm. And as you may recall, most calculators do not have the capability to evaluate a log base 2. So here I need to use change of base. And recall that change of base says that I can rewrite this as log of 2.9 divided by log of 2. Okay, now notice that we are only taking the log of this thing here. See, we're taking the log here. This minus 5 is not something we're taking a log of. So after we evaluate this, we will then subtract the 5. So let's take a look at that. Let's see. Log of 2.9 divided by log of 2. And notice that's kind of what I've got here. And then I'm going to subtract 5. And I end up with negative 3.464. Okay, last example like this. F of x is equal to x minus 5 divided by 2x. Well, which x do I put that 2.9 in for? The top one or the bottom one? The answer is yes. We want to put it in both of those. F of 2.9 is equal to 2.9 minus 5 divided by 2 times 2.9. And let's see what our calculator gives us when we do that. 2.9 minus 5. That whole thing is in parentheses, because we're dividing the top by the bottom, and then 2 times 2.9. So this is kind of how it looks like on my screen. I want to make sure that you kind of have the right idea of putting it in your calculator correctly. And we end up with negative 0.362. Okay, so for this segment, we're going to look at evaluating piecewise functions. And the first thing we want to do is kind of make you aware or familiar with what is a piecewise function. A piecewise function is nothing more than this. It's a function that is defined differently on different pieces of their domain. So many of the functions or graphs that we've been exposed to in the past have had the same type of behavior, or a very continuous kind of predictable behavior. Piecewise functions don't really look that way. They often look choppy, and sometimes there are even jumps in the graph from piece to piece. So if you kind of look at this function, you can see where we have one behavior happening up until this point, and then a different kind of behavior here, slightly different here, and something different here. 4 different things happening on the same graph. This is a piecewise function. I would define this part of the graph differently than this piece, and finally than this piece. This is another example of a piecewise function, where on the left side of the graph I have something that is linear, and on the right side of the graph I've got something that's quadratic. Different pieces of the domain are defined differently. So that gives you an idea of what they look like graphically. What you're going to be asked to do is to evaluate piecewise functions. And I like to kind of think about this as a game show, okay? Take a break from math for a minute and imagine that you are a contestant on Let's Make a Deal, okay? And you are given 3 doors, and you can choose which door your prize is going to be from. And you don't really know which door is which, but you know that there are 3 prizes, okay? So prize number 1 is a trip to Tahiti, yay, right? Trip number 2 is a brand new car. And door number 3 is a goat, yay, right? Maybe if you've got a really big lawn that you need mowed. But you need to choose the right door to get the right prize. So think of these functions as going through the right door to evaluate, all right? This is a piecewise function. This is what it looks like. Notice that these are different pieces, and they're defined differently on different parts of their domains right here. So consider these the doors that we need to go through. Once we go through the door, we don't use that anymore. We have used that part of the definition, and we don't have to use it any longer. So let's say we're asked to evaluate f of 4. Well, we come over here to the doors, and we don't even look at this part. We go, okay, I want to evaluate f of 4. Is 4 less than negative 3? Is 4 equal to negative 3? Or is 4 greater than negative 3? Ding, 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 we have a winner. Okay, so this is the door I'm going to go through. All right, so now what I want to do is substitute that 4 in right here for this x, and then I can evaluate. Okay, so f of 4, this is a bad marker. F of 4 is equal to negative 5 times 4 minus 4. Okay, so let's evaluate this. This would be negative 20 minus 4, also known as negative 24. Okay, not bad, not bad. When you break it down like that, it's not so bad. So let's try f of negative 10. So, is negative 10 less than negative 3? Yes, so that's the door I want to go through. Take it through this door, and then I'm just going to substitute this negative 10 in right here. 2 times negative 10 plus 7. Okay, so this is negative 20 plus 7, also known as negative 13. All right, so the last one of these, let's look. Is negative 3 less than negative 3? No, it's not less than negative 3. Is negative 3 equal to negative 3? There it is. There's our winner. So I go through the door, and then, oh, there's no place to substitute that negative 3 in. But there's my output. There's my output. All I need to do is copy down that, and I am finished. Okay, so this last little segment, we are going to look at how to evaluate functions by synthetic division. Sometimes this is called evaluating functions using the remainder theorem. Okay, either one of those directions are referring to this process. Okay. So, just like the name implies, synthetic division, we're going to apply the rules that we have done with synthetic division. So we're going to look at this function and we're going to set up our synthetic division. Remember, we're taking these terms, placing them in standard form, and then grabbing the coefficients off of them. This is already in standard form, so I can just pull down the coefficients of each term like so. Now, what goes in the box? Remember when we did synthetic division before, we solved for x and that value went in the box. Well, we already have x. X here is a -4, so that -4 goes in the box. Okay, so we're going to proceed through our synthetic division process. Remember, dropping the 3, multiplying by -4, get -12, adding the -12 and 4 to get -8, multiplying here to get 32, adding 32 plus -5 is 27, multiplying by -4, I believe that's -108, and then adding here, so we get -105. Now, if I were dividing, I would express this as a polynomial, right? Where this is the remainder, the constant term, the linear term, and the quadratic term. But this is not what I'm doing. I'm using synthetic division, but I'm using it to evaluate. And what was the other way to say this? We were evaluating using the remainder theorem. Well, that means all I'm interested in here is the remainder. This is my answer. F of -4 is equal to -105. That's easy. You already know synthetic division, so now you're just applying it to get something different than what you were using it before. All right, so let's look at this one and apply what we know. All right, so look here. 5x to the 4th minus 2x squared plus 6x minus 1. So let's go ahead and set this up. Let's see, here's my box. They are in descending order, the degrees of my terms, but what is missing? Well, you notice there's a cubic term missing, so remember we have to use a placeholder there. So we've got 5 for the x to the 4th, 0 for the x cubed, -2 for the x squared, 6 for the x, and a -1 here. Okay, looking good, and we are again evaluating f of -4. Okay. So, again, drop the 5, right? Multiply, add, multiply, add, multiply, 156, 312. Okay, and add. Oh my gosh. And multiply, so let's see. 1224. Okay, so 1223 is my answer there. That's my remainder. So f of -4 here is 1223. All right, see you next time when we talk more about functions and all the fun stuff that we can do with them.